So in this example, we are required to find the value of the definite integral from 1 to 2. We have the x divided by the quantity 3 minus 5x squared. And since we are dealing with substitution, it stands to reason that we apply substitution, and we're going to let, I'm sorry?
That was that almost exact problem was the one that was right above the one that I put up there.
Okay, so the substitution, it stands to reason that we substitute u equal 3 minus 5x, and now we're going to get the differential. Well, the differential du will be u prime times dx. Well, u prime is negative 5, so the differential du is negative 5 dx. And since we need to substitute dx by itself, then dx by itself will be negative du over 5. Oops. Like so. Okay? So now the integral. And now I'm going to adjust the boundaries. Okay, so adjust the boundary. So when x equals 1, u equals 3 minus 5 times 1, or u equals negative 2. And when x equals 2, u equals 3 minus 5 times 2, or negative 7. Okay? So here is something that you may find a little bit unusual, but there is nothing unusual about it in reality. This is the original integral. With the substitution, we first substitute the integrand. Well, we have dx is du is 1/5 du. The integrand itself is 1 over u squared. So we're going to write it as 1 over u squared. And here we have du over negative 5, like so. So we substitute everything except the boundaries. Now the boundaries, when x equals 1, now u equals negative 2. When x equals 2, u equals negative 7. And if you look carefully at the boundaries, we go in reverse. If we go from negative 2, instead of forward, we go backward to negative 7. So we use the property of the integral that states that the integral from a to b is the negative integral from b to a. And we have a negative here, so what we're going to do, we're going to flip the boundaries of the integrals. We're going to take the positive, we're going to take 1 over 5, but positive 1 over 5 outside the boundary of integration. And now we're going to reverse the boundary of integration to change the sign from negative to positive. So now we're going to go forward from negative 7 to negative 2. Okay? And of course we have du over u squared. Well, u squared is u to the negative 2. When you do the antiderivative, you add 1, and it becomes, it's now reverted to a negative stuff. So it will be 1/5. The antiderivative 1 over u squared is negative 1 over 1 over u, like so. Okay? And the boundary is negative 7 to negative 2. So we are back to negative stuff. What you can do, just for practice purpose, if you don't want to have too many negatives, go ahead and flip it again. So you have 1 over 5u positive, and flip the boundary again from negative 2 to negative 7. Okay? You don't have to do so. You don't have to flip anywhere. I mean, you could have started with negative 2 to negative 7 and stay with it and carry the negative value. I did it, to confuse you. Actually, no, I did not do it to confuse you, but I just didn't want to carry the negative up front all the time. But because the antiderivative is negative, I end up flipping and then flipping back. Okay? But the purpose of this is to show you how you work this property of the integral. As every time you flip the boundaries of the integral, you change the sign of the integral. Anyway, now it's about substitution, so you end up having the actual value, the actual calculation will go like this. Negative 1/35 minus negative 1/10. We still have plenty of negative stuff to worry about, right? So we're looking at 1/10 minus 1/35. Common denominator is 70, so we're looking at, I think it's 70. Yes, it is. 7 minus 2. 7 minus 2 is 5/70, or 1/14. Okay, the last two calculation did in my head, but I'm sure you can follow me on this one.